Alright, and this video is going to introduce the multivariable chain rule. And just a reminder that we're going to focus on one version of the chain rule. The textbook has many other versions, and we'll maybe see another version later on in the last video, but it won't be focused on heavily here. Alright, so multivariable chain rule. Okay, well, it'd probably be good to remind us what normal chain rule is in one variable. So if we had a composite function, f of g of x, right, and we're looking at the derivative of this, what we said was, well, we could write this as f of g of x, right, and then we remember that we have to do derivative of the outside, leaving the inside intact, and then times derivative of the inside. That's what we did way back when, and we can certainly do it at a point too. Okay, so now this is going to be largely the same idea. Okay, it's just notation is going to be different. Alright, and so what we're going to see in the chain rule, okay, we're going to write it all out, okay, and we have to do a little bit of remembering of notation from Calc 2, actually. So in this theorem, we have to be given or suppose that we have a function f, and now we have multiple inputs and outputs. So f is going to be defined on a domain x that is a subset of Rp. Okay, roll with me here for a minute. And its output is going to be in Rm. Okay, and we're also going to be given another function x. Okay, and this is going to be defined on a domain T that is a subset of Rn, and its output is Rp. And now why do we do it this way? Well, we know that we have to go from Rn into Rm, right? Okay, for general spaces. Okay, but if we have a composite function, we have to stop along the way at this Rp. Okay, and so what we're going to do is to go from Rn to Rp, that's where x is going to come into play, and to go from Rp to Rm, we're going to do f, but then again, remembering back to Calc 2, when we do the composition to go from from Rn to Rm in general, right, we have to actually do the composition in reverse order, or at least make it look like it's reverse order, but it actually makes sense. So we first deal with x, and then once we get the outputs of x, those are the inputs for f. Okay, alright, so we have those. Alright, we need a little bit more details given to us. So we have these functions such that x is differentiable at t naught in Rn and f is differentiable at x of t naught, which is going to live in Rp. Okay, alright, so those are our conditions. Then, what can we say? Well, we're going to say f of x at t naught, okay, at our point, and I should actually make that a vector since it is in n dimensions. And then if we differentiate this, okay, this is going to equal d of or df of x of t naught, remembering all of our vector arrows, and then times d of x of t naught. Okay, so exactly similar to what we thought, but in the one variable case, we have derivative of the outside, right, in quotes, and then this is the inside. Okay, but the more important thing that I want to remember is the dimensions. So we know that this first one, right, this is an m by n dimension. Okay, if I were to look at that entire thing, this is m by p, and then this would be p by n. I'm going to have you pause the videos and verify that, but I'm fairly certain we do that. And so then matrix multiplication is going to work because we have these two matching. Okay, and then the resulting thing is m by n. Okay, so this should work out in theory. Alright. Alright, multivariable chain rule, check. Let's go through an example. But we're going to go through an example in two ways, so this video is going to be a little longer than normal. Alright, so first thing, we just want to use the definition. Okay, we're going to use the definition. Alright, so this is going to be d of g of f of 1, 2, and here I should make this into a vector, but I'll just skip that for right now. Yeah, these should be vectors. Okay, vectors, 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 and then times d of f of 1, 2. Alright, so I should probably do some work off to the side here. So let's just kind of come over here. Let's do dg. Okay, and we got really good at this last week, so my answer is going to be 3y, 0, 3x, negative 1, 14y. Okay, and then I'm also going to do df off to the side, so df is 2x, 2y, and then y and x. Okay, so I believe at the end of the day, if you were to compute this, I believe, let's see, f of 1, 2, I believe we end up getting, this is d of g of 5, 2. Okay, I'll let you verify this. Again, I'm just kind of going through the math quickly. And then times d of f of 1, 2. Oops. Okay, and then let's see, so this is going to end up being dg of 5, 2 ends up being 6, 1, 0, 15, negative 1, 28, and then f is going to be 2, 2, 4, 1. Okay, and then multiplying it all together, I end up with 42, and then 0, 56, that's a 6, and then 39, 3, and 28. Okay, so that would be my final answer. Again, I skipped a lot of the algebra and the computation. Okay, so this is going to be fine. Okay, that's one way, just using the definition. The second way we can do it is actually a way to skirt around the chain rule, and let's just do the composition first and then differentiate. Okay, so that is to say we're going to find h of xy, that is g of f, okay, again, remember my vector notation. All right, and so what this ends up being is 3x cubed y plus 3 3xy cubed x squared plus y squared minus xy, and 7x squared y squared. Alright, and then you can go through and find the derivative matrix, so dh, and what you end up getting here is 9x squared y squared, or y plus 3y cubed, and then 2x minus y, 14xy squared, and then let's see, we get 3x cubed plus 9xy squared, 2y minus x, and then 14x squared y. Okay, and then you would go through and find dh of 1, 2. Okay, and what you end up getting is the same as above. Okay, so either method works, and the second route actually avoids the chain rule entirely. It's up to you. We may ask you in homework or exam problems to very clearly show us that you understand the chain rule, which will require you to use the first method instead of the second. So make sure that even though you can go around it and do the composition first and then differentiate, that you are still able to do that first method. And we have one more video to wrap this section up.